Hey there, so for this video, we're going to practice using the Pythagorean theorem. Remember, we can use this amazing theorem anytime we have a right triangle. A reminder, a right triangle always includes one 90-degree angle. Usually it's annotated by this symbol right here, or in the problem itself, in the written directions, they might tell you that it's a right triangle. So again, if we have a right triangle, we can use the Pythagorean theorem. So let's do an example here. I have an example here where we have a right triangle. We have the height of it is 5, the length of it is 9, and what we need to do is we need to find out what x is. Okay, so we're going to use our Pythagorean theorem. And a reminder, our Pythagorean theorem says that a squared plus b squared equals c squared. So as long as we know 2 out of the 3, we can solve for whatever missing side length that we're looking for. So for this example here, we're looking for the hypotenuse. Remember which is C. We can call this leg A. We can call this leg B. Our hypotenuse is always C. A reminder about the hypotenuse, remember we can always tell which side is the hypotenuse because it's directly across from your 90-degree angle. So that's how you can identify your hypotenuse. The other two are legs. Doesn't matter which one you call A or which one you call B, but those are the legs of your triangle, and then our hypotenuse is C. So let's go ahead and solve for x for this problem. So we're going to just substitute into our formula a squared plus b squared equals c squared, and we're going to solve. So our a for here we have identified as 5. So I'm going to put in there 5, and then I'm going to square it following our formula. Our b value is 9. So again, I'm going to substitute in 9 where I see b, and I'm going to square it, again, according to our formula. And then this is going to continue to equal c squared because c is what we're solving for. So now we have math. Now we've got some math. We've translated what they've given to us in our diagram, and we're substituting it into our mathematical equation so we can solve. So if we take 5 squared, remember, 5 squared does not mean 5 times 2. Remember, 5 squared actually means 5 times itself 2 times. So that's important to remember. So 5 squared would be 5 times 5, which is 25, plus 9 squared, which is 9 times 9, which is 81. And then again, that still equals c squared. We don't have any value to substitute in for c yet. That's what we're solving for, so that remains c squared. So now what we're going to do is just do math. We're going to take 81 plus 25, and we get 106. So we get 106 equals c squared. Now remember, we're looking to see what c is, which for our example here is x. We don't want to know what c squared is, so we want to get it to where c is all by itself. Now, just like when we're solving equations and we have 3x equals 18, to solve for x, we need to divide both sides by 3 because 3 is being multiplied by x. We're doing the opposite, so we're dividing it to solve for x. Same concept here when we have squares. We want to do the opposite operation of squaring something, which is taking the square root. And what we do to one side, we're going to do to both sides. So we're going to take the square root of c squared, and then we're also going to take the square root of 106. So when we do that, our squareds cancel out, and we're left with just c, and we have the square root of 106. So we can either use our calculator and take the square root of 106 and find out what that decimal value is, if they allow us to do that. Sometimes when we're looking for a result, they want us to keep it in the form of a radical or a square root. So if we were to do that, what we would do is we would take 106 and keep reducing down until we can get it simplified no further. So we know that 106 is even. So we know 2 times 53 would be 106. Well, 53 is also, that's prime, and 2 is prime. So ultimately, we could leave this as c equals the square root of 106. Or we could take our calculator, plug in 106, and hit the square root button, and see that c, the square root of 106, is also 10.30 if we're rounding. So either one of those answers should be acceptable. So we have found that our value of 6 is either 10.3 or square root of 106. And that would be our answer for that example. Not so bad, not so bad. It doesn't look pretty when it gets down here. It looks a little scary, but it's not bad at all. If we just reduce it down, all we had were prime numbers. There is nothing out that we can take. So we can either leave it as a decimal or the square root of 106. Awesome. Let's try one more. So for our second example, we have this triangle here. We know that it's a right triangle because we're given that symbol here to show us that we have a right angle inside this triangle. And let's write down the Pythagorean theorem to remind ourselves. So that's going to be a squared plus b squared equals c squared. All right. So notice for this problem, the hypotenuse, remember, is always across from the 90-degree angle. And the hypotenuse is our c value. So I'm going to put equals c there. Remember, the legs of the triangle are A and B. So we have one here that we don't know, and we have one leg that we do know. So let's call the leg that we do know A, and B is the value that we're looking for. We don't know what that side length is. We're asked to find the side length. So this is the side length that we're looking for, which is B. So remember from our last example, what we're going to do is we're just going to substitute in our values into our equation and solve for our unknown value for this problem is B. So our A is 3, so we're going to substitute in 3 and square it. We don't know what B is, so we keep that the same. And our C value in this example is 5. So we're going to substitute that in where we see C. So now we have 3 squared plus b squared equals c squared. And we're looking to solve for b. No problem. So again, remember 3 squared means 3 times 3. So 3 times 3 is 9. Plus b squared, we don't know what that is, so that's going to remain the same, equals 5 squared. And we know 5 squared means 5 times 5, which is 25. So now we have 9 plus b squared equals 25. We are looking to solve for b, remember. So we want to get b by itself. So we want to move the 9 over to the other side. Since the 9 is positive, remember we do the opposite. So we're going to subtract 9. And what we do to one side, we do to both sides of an equation. We're not changing the value of the equation, we're changing how it looks. So we're going to go ahead and do that. Our 9s are going to cancel out. On the left side, we're left with b squared. 25 minus 9 is 16. So now we have b squared equals 16. Reminder, we're not looking to find out what b squared equals. We want to know what b equals. Since we have a b squared, we're going to do the opposite operation to squaring something to be able to change the value of that and find out that value. So we're going to take the square root of b squared. What we do to one side, we have to do to the other side. Take the square root there also. So now we have b, because now we have b, because our squared cancels with our square root, equals the square root of 16. The square root of 16 is a perfect square. We know that that is 4. So we have found that our side length B is the value of 4. I hope this instruction helped. I hope you feel more comfortable with the Pythagorean theorem. If you need any more help, just reach out.